So in the last lecture, we saw how to use the input and print statements to collect input from the standard input, that is the keyboard, and to display values on the screen using print. Now this is useful for small quantities of data, but if we want to read and write large quantities of data, it is impractical to type them in by hand or to see them as they scroll past on the screen. So for large data, we are forced to deal with files which reside on the disk. So we have to read a large volume of data which is already written on a file in the disk, and the output we compute is typically written back into another file on the disk. Now, one thing to keep in mind when dealing with disks is that disk read and write is very much slower than memory read and write. So to get around this, most systems will read and write data in large blocks. Imagine that you have a large storage facility in which you store things in big cartons. Now, when you go and fetch something, you bring a carton at a time, even if you're only looking for, say, one book in that carton. So you don't go and fetch one book out of the carton from the storage facility. You bring the whole carton, and then when you want to put things back again, you assemble them in a carton and then put them back. So in the same way, the way that data flows back and forth between memory and disk is in chunks called blocks. So even if you want to read only one value or only one line, it will actually fetch a large volume of data from the disk and store it in what is called a buffer. And then you read whatever you need from the buffer. Similarly, when you want to write to the disk, you assemble your data in the buffer, and when the buffer is enough quantity to be written onto the disk, then one chunk of data in a block will be written back on a disk. So when we read and write from a disk, the first thing we need to do is connect to this buffer. So this is called opening a file. So when we open a file, we create something called a file handle, and you can imagine that this is like getting access to a buffer from which data from that file can be read into memory or written back. Now, having opened this file handle, everything we do with the file is actually done with respect to this file handle. So we don't directly try to read and write from the disk. Instead, we read and write from the buffer that we have opened using this file handle. And finally, when we are done with our processing, we need to make sure that all the data that we have written goes back. So this is done by closing the file. So closing the file has two effects. The first effect is to make sure that all changes that we intended to make to the file, any data we wanted to write to the file, is actually taken out of the buffer and put onto the disk. And this is technically called flushing the buffer. So closing a file flushes the output buffer, makes sure that all writes go back to the file and do not get lost. And the second thing it does is that it, in some sense, makes this buffer go away. So it disconnects the file handle that we just set up. So now this file is no longer connected to us. If we want to read or write to it again, we have to again open it. So the command to open a file is just open. So the first argument that you give open is the actual file name on your disk. So now this will depend a little bit on what system you're using, but usually it has a first part and an extension. So this command, for instance, says to open the file gcd.py. Now implicitly, if we just give a file name, it will look for it in the current folder or directory where you're running the script. So you can give a file name which belongs to a different part of your directory hierarchy by giving a path, and how you describe the path will depend on whether you're working on Windows or Unix or what operating system you're using. Now you see that there is a second argument there, which is the letter R. So this tells us how we want to open the file. So you can imagine that if we are making changes to a file by both reading it and writing it, this can create confusion. So what we have to do is decide in advance whether we are going to read from a file or write to it. We can't do both. So there's no way we can simultaneously read from a file and modify it while it is open. So read is signified by R. Now write comes in two flavors. We might be wanting to create a new file from scratch. In this case, we use the letter W. So W stands for write out to a new file. We have to be a bit careful with this, because if we write out to a file which already exists, then opening it with more W will just overwrite the contents that we already had. The other thing which might be useful to do is to take a file that already exists and add something to it. So this is called append. So we could have two writing modes, W for write and A for append. What append will do is it will take a file which already exists and add the new stuff that we are writing at the end of the file. So once we have a file open, let's see how to read. So we invoke the read command through the file handle. So this is like some of the other functions that we saw with strings and so on, where we attach the function to the object. So fh was the file handle we opened. So we want to read from it. So we say fh.read. What fh.read does is it swallows the entire contents of the file as a single string and returns it. And then we can assign it to any name. Here we have used the name contents. So contents is now assigned the entire data which is in the file handle pointed to by fh in one string. Now we can also consume a file. So we are typically dealing with text files. So text files usually consist of lines. Think of Python code, for example. We have lines after lines after lines. So a natural unit is a bunch of text which is ended by a new line character. If you remember, this is what the input command does. The input command waits for you to type something and then you press return, which is a new line, and whatever you typed up to that return is then transmitted by input as a string to the name that you have assigned to the input. So read line is like that, but the difference between read line and input is that when you read a line, you get the last new line character along with the input string. So when you say input, you only get the characters which come before the last new line. The new line is not included. But in read line, you do get the new line character. So you have to remember that you have this extra character floating around at the end of your string. So this is conventionally denoted by this \n. So \n is a notation which denotes a single character, even though it looks like two characters. This is supposed to be the new line character. Now the actual new line character differs on operating systems from one to the other. But in Python, if you use \n, it will be correctly translated in all the systems that you're using. The third way that you can read from a file is to read all the lines one by one into a list of strings. So instead of read line, if I say read lines, then it reads the entire file as a list of strings. Each string is one item in the list. And this, remember again, each of these lines has the \n included. So read line and read lines, none of them will actually remove the \n's. They will remain faithfully as part of your input. So in other words, if you're going to transfer this from one file to another, you don't have to worry about reinserting \n because it's already there. So you can use this input to output directly. But on the other hand, if you want to do some manipulation with the string, then you must remember that this \n is there and you must deal with it appropriately. Reading files is inherently a sequential operation. Now, of course, if we use the basic command read, it reads the entire contents. So obviously it reads it from beginning to end. But if we are reading one line at a time, then the way it works is that when we open the file, we are initially at the beginning of the file. So you can imagine a pointer like this red arrow, which tells us where we are going to read next. So initially when we open, we are going to read from the beginning. Now each read line takes us forward. So if I do a read line at this point, it will take me up to the next \n. Now remember, a line is a quantity which is delimited by \n. So we could have a line which has 100 characters, next line could have 3 characters, and so on. So it is from one \n to the next is what a line is. So this is not a fixed length. So we will move forward reading one character at a time until we have \n. Then everything up to that \n will be returned as the effect, the string returned by read line, and the pointer will move to the next character. Now we do another read line, possibly of a different length. Again, the pointer will move forward. So in this way, we go from beginning to end. In case we want to actually divert from this strategy, there is a command seek, which takes a position, an integer n, and moves directly to position n regardless of where you are. So this is one way to move back or to jump around in a file other than by reading consecutively line by line. Finally, we can modify the read statement to not read the entire file, but to read a fixed number of characters. Now this may be useful if your file actually consists of fixed blocks of data. So you might have, say for example, PAN numbers, which are typically 10 characters long, and you might have just stored them as one long sequence of text without any new lines, knowing that every PAN number is 10 characters. So if you say fh.read 10, it will read the next PAN number and keep going, and this will save you some space in the long run. So there are situations where you might exploit this, where you read a fixed number of characters. Now when we are reading a file incrementally, it's useful to know when the file is over, because we may not know in advance how long the file is or how many lines the file is. So if you're reading a file line by line, then we may want to know when the file has ended. So there are two situations where we will know this. So one is if we try to read using the read command and we get nothing back, we get an empty string, that means the file is over. We have reached the end of file. Similarly, if we try to read a line and we get the empty string, it means we have reached the end of file. So read or read line, okay, if they return the empty string, it means that we have reached the end of the file. Remember, we're going sequentially from beginning to end. So we've reached the end of the file and there's nothing further to read in this file. So having read from a file, then the other thing that we would like to do is to write to a file. So here is how you write to a file. Just like you have a read command, you have a write command. But now, unlike read, which implicitly takes something from the file and gives it to you, here you have to provide it something to put in the file. So write takes an argument which is a string. Right? So when you say write s, it says take the string s and write it to a file. Now there are two things. One is this s may or may not have a \n. It may have more than one \n. So there's nothing that tells you that this is one line, it's part of a line, more than a line. You have to write s according to the way you want it to be written on the file. If you want it to be one line, you should make sure it ends with a \n. And this write actually returns the number of characters written. Now, this may seem like a strange thing to do. Why should it tell you? Because you know from the length of s what is the number of characters written. But this is useful if, for instance, the disk is full. Right? So if you try to write a long string and you find out that only part of the string was written, then this is an indication that there was a problem with the write. So it's useful sometimes to know how many characters actually got written out of the characters that you tried to write. So the other thing which writes in bulk to a file is called write lines. So this takes a list of strings and writes them one by one into the file. Now, though it says write lines, these need not actually be lines. So it's a bit misleading, the name. Okay? If you want them to be lines, you must make sure that you have each of them terminated by \n. If they are not, then they will just cascade to form a long line in the thing. So though it says write lines, it should be more like write a list of strings. That's a more appropriate name for this function. It just takes a list of strings and writes it to the file pointed to by the file handler. And finally, as we said, once we are done with the file, we have to close it and make sure that the buffers that are associated with the file, especially if we are writing to a file, that they are flushed. So fh.close would close the file handle fh. And all pending writes at this point are copied out to the disk. It also now means that fh is no longer associated with the file we are dealing with. So after this, if we try to invoke operations on fh, it's like having an undefined name in Python. Now, sometimes there are situations where we might want to flush the buffer without closing the file. We might just want to make sure that all writes up to this point have been actually reflected on the disk. So there is a command flush which does this. So in case we say flush, it just say if there are any pending writes, then please put them all onto the disk. Don't wait for the writes to accumulate until the buffer is full and then write as you normally would to the disk. So here is a typical thing that you would like to do in Python, which is to process it line by line. So the natural way to do this is to read the lines into a list and then process the list using a for. So you say contents is fh.readlines, and then for each line in contents you do something with it. You can actually do this in a more compact way. You can do away with the name contents and just read directly every line returned by the function fh.readlines. So this is an equivalent formulation of the same loop. So as an example of how to use this line by line processing, let us imagine that we want to copy the contents of a file input.txt to a file output.txt. So the first thing that we need to do is to make sure that we open it correctly. So we should actually open the out file with mode W and in file with mode R. Okay? So this says that I'm going to read from in file and write to the out file. Now for each line in returned by read lines on the in file. Remember that when I get a line from read lines, the backslash n is already there. And if I don't do anything to the backslash n, I can write it out exactly the same way. So for each line that I read from the list in file.readlines, I just write it to out file, and finally I close both the files. Okay? So this is one way to copy one file from input to output. So of course, we can do it even in one shot, because there is a command called write lines, which takes a list of strings and writes them in one shot. So instead of going line by line through the list read lines, we can take the entire list contents and just output it directly through write lines. So this is an alternative way where I have replaced, so this is basically replacing the for, right? So instead of saying for each line in files, okay, I can just write it directly out. So one of the things we have been talking about is this new line character, which is a bit of an annoyance. So if we want to get rid of a new line character, remember this is only a string, and the new line character is going to be the last character in the string. So one way to get it is just to take a slice of the string up to but not including the last character. Now remember that when we count backwards, -1 is the last character. So if we take the slice from 0 up to -1, then it will correctly exclude the last character from the string. So s equal to line colon -1 will take line and strip off the last character, which is typically the backslash n that we get when we do read lines. Now in general, we may have other spaces. So remember, when we write out text, very often we can't see the spaces at the end of the line because they're invisible to us. So these are what are called white space. So spaces, tabs, new lines, these are characters which don't display on the screen, especially spaces and tabs. And if they're at the end of the line, we don't know whether the line ends with the last character we see or there are spaces afterwards. So rstrip is a string command which actually takes a string and removes the trailing white space, all the white space at the end of the line. In particular, if there's only a backslash n, then it will strip the backslash n. It will also strip other junk if there is some spaces and tabs before the backslash n, and return that. So s equal to line.rstrip, that is strip line from the right of white space. Okay? This is an equivalent thing to the previous line, except it's more general because it strips all the white space, not just the last backslash n, but all the white space at the end of the line. So we can also strip from the left using lstrip, or we can strip on both sides if we just say strip without any characterization of L or R. So these are string manipulation functions, and we will look at some more of them, but this is just a useful one which has come up immediately in the context of file handling. So before we go ahead, let's try and look at some examples of all these things that we have seen so far. So here we have created a file called input.txt, which consists of the lines, "The quick brown fox jumps over the lazy dog." Now let's open the Python interpreter and try to read lines from this file and print it up. So we can say, for instance, that f is equal to open input.txt in read mode. Okay, now I have opened the file, and now I can say, for instance, for line in f.read line print line. Now you'll see something interesting happening here. So you'll see that we have now a blank line between every line in our file. Now why is there a blank line between every line in our file? That's because when we read lines, we get a backslash n character from the line itself. So the quick brown, the first line, ends with backslash n. Fox ends with backslash n. And then over and above that, if you remember, the print statement adds a backslash n of its own. So actually print is putting out two blank lines for each of these. So now let us try and do this again. Okay, so supposing I repeat this thing, and now I do this again. Now nothing happens. Now the reason nothing happens is because we have this sequential reading of the file. So the first time we did f.read lines, it read one line at a time, and now we are actually pointing to the end of the file. So if, for instance, at this point we were to say text equal to fh.read, right? Sorry, f.read, then text will be the empty string. So this is an indication that we have actually reached the end of the file. Similarly, if we try to say read line, again text will be the empty string. So remember, we said that if read or read line returns the empty string, then we have reached the end of the file. So the only way that we can undo this is to start again by closing the file. So what we say is f.close. So this closes the file. Now if we try to do f.read, then we will get an error saying that this is not been defined. Okay, so we don't have f with us anymore. So we again have to say f is open input.txt r, and now we can say while for line in f.read lines for each line. Supposing now we use that trick that we had last time, which is to say end equal to empty string that says do not insert anything after each print statement. Okay. Now if we do this, we see that we get back exactly the input file as it is without the extra blank lines, because print is no longer creating these extra lines. So let's say we want to copy input.txt to a file output.txt. Right? So we say f is equal to open input.txt r as before, and we say g is equal to open output.txt w. And now we say for line in f.read lines, g.write line. Okay. Now notice you get a sequence of numbers. Now why do you get a sequence of numbers? That's because each time we write something, it returns a number of characters written, and it will turn out, if you look at the lines, the quick brown fox, etc. Now for example, the second line is just fox. Fox has 3 letters, but if you include the backslash n, it wrote 4 letters. Right? So that's why the quick brown was 15 letters plus a backslash n. Fox was 3 plus a backslash n. So this is line by line. Now if I correctly close these files, and then come out of this, then output.txt is exactly the same as input.txt. So to summarize, what we have seen is that if we want to interact with files, we do it through file handles, which actually correspond to the buffers that we use to interact between memory and the file on the disk. We can open a file in one of 3 modes: read, write, and append. We didn't actually do an example with append, but if you do append, what it will do is it will keep writing beyond where the file already existed. Otherwise, write will erase the file and start from the beginning. So we saw that we have read, read line, and read lines. So using this, we can either read the entire file in one shot as a string, or read it line by line. Similarly, we can either write a string, or we can write a list of strings too. So we have a write command and a write lines, and write lines is more correctly to be interpreted as write list of strings. Finally, we can close the handle when we are done, and in between we can flush the buffer by using the flush command. And we also saw that there are some string operations to strip white space, and this can be useful to remove these trailing backslash n's which come whenever we're processing text files.